Hello everyone. I wanted to show off a project that I recently made. It's the A pathfinding algorithm implemented in Python. So what it does, it finds the shortest path between the violet starting point and the green endpoint in a pretty efficient manner. I can remove and add walls, as you can see. And here the blue line, this is the correct solution that it found. There are often multiple correct solutions, but it just chooses one of them. And all the pink squares are the ones that it had to check in order to be sure that it is the correct solution or the best solution. Here I can scale it up to maybe 30 by 30. Then of course I have to draw more walls, but you can make more detailed mazes or whatever. And here you can see how it works a bit. It row by row checks the closest squares, and once it finds a direct connection to the endpoint, it can just go there. You can also try it on a smaller scale if you want to. I think this is 10 by 10. By the way, if you want to use it later, it's on my GitHub, and you can scale up and down with the arrow keys. So let's look in the code for a moment. Here at the top I have the parameters that you can tweak however you want to. I was too lazy to implement them in the code, so you have to adjust them here. So let's make draw text true, and then we can see how it works. It is a bit laggy though if I draw the whole text, and I was too lazy to optimize it. So here you can see there are 3 numbers in each square. There's one at the top left that indicates the estimated distance to the endpoint. There's one at the top right that indicates the estimated or the best possible distance to the starting point, and the number below those two is the sum of the upper two. Here you can see how it works. So it checks the lowest number one after another, and if it repeats that, it will eventually get to the goal. It also prefers the numbers, so if there are 2 equal numbers, it chooses the one that's closer to the endpoint. Here we have the 110 with the distance 90 and another one with the distance 76, and it chose the one with the 76. And this leads to the behavior we saw earlier, that once it has a clear path to the endpoint, it just takes that path, and it doesn't have to check any other paths. So let's remove the text again, and I will tweak a few parameters. If you want, you can try it for yourselves later too. So yes, that's interesting. So now it will show the path instantly and do not do the animation, and also it won't show the pink squares that it checked. In my opinion, this looks a bit more boring, but if you just want to create the correct path, this is of course the faster way. By the way, if it finds no solution, it's all pink and nothing happens. Or in this case, the path wouldn't have shown. You can also disable diagonals, which I implemented because a friend asked me to. And yeah, I think it just looks even more boring this way. I think there could even be a simpler algorithm to do it on this grid, but who cares? By the way, if you hear birds in the background, I'm recording this with an open window and it's spring, so I hope those aren't annoying. So let's take a look at the code for a moment. You can see I have a node class and a graph class. The node class is, mathematically speaking, just a connection of edges, and so it's a vertice, and the graph class contains all those nodes. So one node in a simulation is a square. Yeah, if you play around with yourself, you can do whatever you want to it. So let's do size 100. It will probably not look very nice, but it still works. There you can see the line there, but 100 is a bit too much. Yes. Yeah, I just like to play around with it, sometimes when I'm bored or when I procrastinate another thing. And while we're at it, let's also remove the random class that's unnecessary here. I think I had it for testing or something. By the way, the A Pathfinding algorithm does not only work for grids like the one you can see here, but for any graph, so a mathematical graph that you can imagine, if it is fully connected. If you want to take a look at the code yourself, you can download it from my GitHub repository. The link to it is in the description. So it's just where the code is stored. So that's it. I hope you enjoyed the video. If you have any questions or whatever, you can ask them, of course. But now I won't steal any more of your time. Yeah, have fun playing around.